In the icy shadow of Jupiter lies Europa, a world that at first glance looks like a lifeless frozen sphere. Its surface, crisscrossed with endless scars and brownish ridges, shines brighter than our moon. There are no mountains or deep craters disturbing its smooth ice. This calm frozen facade hides something beneath it. What if Europa holds the most important secret of the solar system? Many spacecraft have gazed upon Europa. From the first images taken by Voyager in 1979 to more recent flybys, each glance revealed a strangely youthful face. Unlike our moon pockmarked with craters, Europa's plains appear utterly flat like a huge ice pack, recalls one of the Voyager project scientists, amazed at the absence of impact scars. Something is resurfacing Europa, erasing the ancient craters. The ice itself seems to be in motion, as if driven by a hidden force. Could a secret ocean beneath the surface be the cause? In this documentary, we'll journey through the clues and mysteries of this distant moon, fractured ice, a hidden ocean, sources of dark energy, and they all lead to one persistent question: could life thrive beneath the ice? Music. Let's start with the fact that Europa's icy shell is far from featureless. On the contrary, it's carved with long winding cracks and marked with chaotic patterns. Dark lines, some stretching over 1,000 miles, cut across the moon's face like fractures on a colossal frozen lake. These lines, known as linea, sometimes run parallel or intersect, forming a global web. Amazingly, when studying Voyager and Galileo images, scientists noticed that opposing sides of some cracks matched up like puzzle pieces. It's as if the icy crust split apart and shifted with dark material seeping up to fill the gaps. Broken chunks of ice rafted into new locations, much like ice floes drift and freeze in Earth's polar oceans. In some parts of Europa, chaos reigns. There are regions the size of entire cities where the surface appears shattered and refrozen. Blocks of ice are tilted and rotated, surrounded by hummocky terrain and refrozen slush. Scientists fittingly call this terrain chaos. It resembles an ice mass partially melted from below, then frozen again into a jumble of layers. These disordered blocks, like massive icebergs, hint that warm soft ice or even liquid water rose from beneath. In other areas, dome-shaped bulges rise upward, while pits mark potential sites where ice has sunk. These features suggest an active ice shell, possibly rising and falling over a hidden ocean. The question arises, what makes the ice move as if it's alive? We observe similar parallels even on Earth. In our Antarctic seas, ice plates drift, crack, and pile up over the ocean. On Europa, we suspect a similar ice interaction, but driven not by wind or current, but by forces from within. Evidence of subsurface influences is everywhere. Smooth plains and few craters suggest that some process is continually refreshing the surface. Could it be cryovolcanism, where slushy water oozes out and refreezes, or settling and shifting of the ice shell floating on a layer of liquid? By the 1990s, scientists increasingly believed these surface clues pointed to a momentous discovery: an ocean beneath the ice. The idea of an ocean inside Europa moved from speculation to reality by the late 20th century. NASA's Galileo spacecraft orbiting Jupiter in the 1990s carried instruments that probed Europa's secrets up close. With every flyby, Galileo confirmed more hints of a hidden sea. It measured the moon's gravity and found its density and moment of inertia matched a thick shell of water ice covering a rocky interior. Moreover, Galileo detected something strange in Europa's magnetic environment. As the probe flew past, Jupiter's powerful magnetic field was disrupted in the space around the moon. The best explanation: Europa was responding with its own induced magnetic field, one created by currents and a massive conductor beneath the surface. Given what we know of the moon's composition, the likely conductor is a global ocean of salty water. Cameras and spectrometers also supported the ocean theory. Galileo's images showed specific patterns on the surface that only made sense if the outer ice could decouple from the interior. For example, the longest cracks did not align with where they should have been if the crust were firmly anchored to the core, but they matched exactly with a scenario where the crust could slide over a liquid layer beneath. Additionally, Europa's two largest impact scars feature concentric ring structures as though an asteroid had pierced the ice and struck something softer below. All of these signs pointed to one conclusion: Beneath the moon's icy shell lies a layer of liquid water. But how can a moon so far from the sun contain liquid water? The answer came from understanding Europa's interaction with Jupiter. It exists in a gravitational tug-of-war with Jupiter and neighboring moons. As it orbits, immense tidal forces stretch and compress its interior, flexing the crust by up to 30 yards. This constant bending generates internal friction, like kneading dough or rubbing hands together to create heat. The friction provides a steady energy source, and it prevents the interior liquid from freezing. Essentially, Jupiter's gravity is Europa's furnace. Calculations show this tidal heating is more than sufficient to maintain a deep global ocean beneath the icy shell, which is estimated to be about 9 to 15 miles thick. Beneath this shell, the ocean may reach depths of around 60 miles, holding more than twice the volume of all of Earth's oceans combined. Today, the existence of a subsurface ocean on Europa is widely accepted within the scientific community. It's now often classified as an ocean world. It's believed that its icy crust floats above a salty sea, beneath which likely lies a rocky seabed and a metallic core. The presence of this ocean opens up the potential for intriguing geology and possibly biology. Essentially, Europa's ice is not a static shell. It's a dynamic, shifting lid atop a hidden ocean, water warmed by Jupiter's gravitational pull. If a dark ocean hides beneath Europa's ice, the next question is, what kind of energy could sustain it, especially if life is present? Sunlight cannot reach the depths. It's blocked by miles of ice and lies in perpetual darkness. Yet, life as we know it requires energy. On Earth's surface, nearly all ecosystems are powered by sunlight. However, deep in the oceans thrives another realm independent of sunlight. Around hydrothermal vents on the seafloor, quirky and downright bizarre organisms live off chemical energy. From these vents gush superheated water rich in minerals and chemicals which specialized microbes convert into food. Towering black smoke vents teem with tubeworms, mollusks, and blind crabs, a whole community nourished by the Earth's inner heat. Could Europa have its own hydrothermal oasis? Planetary scientists believe this is possible and even likely. Beneath the moon's ocean lies a rocky mantle and a core. The rock is constantly flexed and heated by tidal forces just like its ice, and this could lead to geological activity on the seafloor. If parts of Europa's seafloor are hot enough, water interacting with the warm rock could erupt as hydrothermal vents on the ocean floor just as they do along Earth's mid-ocean ridges. New computer models suggest that low-temperature hydrothermal vents could exist on the dark ocean floors of moons like Europa for billions of years. In other words, even without a fiery volcanic core, internal heat could drive vent systems that last over geological timescales. These vents would provide both heat and a chemical buffet, exactly the kind of nourishment simple life could thrive on. They release hydrogen-rich fluids and nutrients, creating chemical gradients that microbes could use as energy sources. Such environments are considered one of the possible cradles of life on early Earth. Unlike the dramatic black smokers that require intense volcanism, Europa might host gentler, warm vents, which actually circulate much more water on Earth and may last far longer. The key point is that its ocean floor need not be a volcanic hellscape. It tickles the imagination. Could life dwell in the pitch-black sea of Europa? But the essence is this: when searching for life beyond Earth, scientists have long drawn up a list of intriguing places. Mars with its ancient rivers and lakes once seemed like an obvious target. Saturn's moon Titan boasts methane lakes and a dense atmosphere, exotic, but perhaps too cold and chemically alien for Earth-like life. In recent years, the search for extraterrestrial life has shifted from Mars to Europa, and for a good reason. Europa hits the trifecta of habitability, water, energy, and the right chemistry. First, water is the essential solvent for life as we know it. This moon has plenty. In fact, it's the wettest known world in the solar system. Beneath its crust lies an ocean that potentially holds twice as much liquid water as Earth. Second, energy. Life needs a power source. Europa's icy cover lacks sunlight, but as we've seen, tidal heating provides internal warmth, and potential hydrothermal vents supply chemical energy. What's more, Jupiter's radiation plays a paradoxical role. It bombards the moon's surface ice, splitting molecules and producing oxidants like oxygen and hydrogen peroxide. These oxidants could migrate downward into the ocean, feeding microbes in the dark. According to recent estimates, Europa's surface produces about 1,000 tons of oxygen daily through radiation chemistry, and that's enough to support 1 million people for 24 hours. Third, chemistry. The building blocks of life such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur must be present. Europa formed with a share of these common elements, and additional organic material likely arrived over time via comet and asteroid impacts. Studies suggest its subsurface ocean is likely salty and rich in minerals. In fact, spectrometers have detected surface compounds hinting at its chemistry. For example, ordinary salt or sodium chloride appears to be present on parts of the crust, giving it a yellowish tint, which suggests the ocean may resemble Earth's salty water in composition. Also, the JWST recently detected carbon dioxide ice in the young geological regions. This is strong evidence that carbon from the ocean is reaching the surface. It appears all the ingredients for life's chemistry, from water to organics, are present. And now compare Europa with its competitors. Mars today is a frozen desert with little liquid water. Enceladus, a tiny moon of Saturn, has a subsurface ocean and even active geysers, and in fact, Enceladus is also high on the list of candidates for life. But Enceladus ocean is smaller, and perhaps life would have a harder time emerging in such a tiny world. Titan has an internal water ocean and an abundance of organic molecules on the surface, but its frigid hydrocarbon lakes are a very alien environment for life. Ganymede and Callisto, other large moons of Jupiter, likely have deep oceans, but their ice shells are thicker and less active, possibly limiting the exchange of nutrients. By contrast, Europa seems to strike the right balance: a large, long-lived ocean, active geology for nutrient circulation, and a steady energy supply. According to Kurt Neber, NASA's lead scientist for outer planet exploration, quote, "Europa is the most likely place to look for life beyond Earth today. It meets the requirements for habitability better than almost any other place in the solar system."